So case 3b, I have a triangular surface. Right, with an angle theta here and here, right? Then I have a pulley on it. Upon the pulley is a rope, and to each end of the rope is a mass. Towards the pulley is your tension. Towards the pulley is your tension. And provided this is your M1 and this is your M2, where M1 is greater than M2, it means this side is heavier than the other side. So what happens to the weight of the body? The body comes down, and coming down, acceleration due to gravity is positive because the body is coming in favor of gravity, right? So I have plus m2g as my weight, but then it is inclined at an angle, so I have sine theta. If this is positive, what happens to your tension? Your tension becomes negative. For this mass, the mass is moving upwards, and the body projected upwards, the gravity is usually negative. Hence, the weight of this body would be minus m2g sine theta. So what happens to acceleration? The body accelerates this way. So I have acceleration here. But then since it is a rough surface, there is coefficient of friction present between the triangular surface and the masses. So you have your coefficient of friction. The coefficient of friction here is your coefficient of kinetic friction. Now, the same coefficient of friction we have here would be the same here because the surface here is the same as the surface here. So if that is the case, you have your mu to be unknown. Since this body is projecting downwards, friction will be opposite it, right? Opposite motion, because motion is going this way. Does that make sense? And you have a frictional force Fr. A frictional force Fr is equals to mu r. Right. What happened to your frictional force here? The motion is going this way, right? And since motion is going in that direction, your frictional force will be opposite this. And so you have your Fr will be equals to mu r. Since this is negative, what happens to your tension? Your tension becomes positive, and the friction is also pointing to this direction, right? And to tension which is pointing to this direction, they are in opposite direction, and hence they are opposite vectors. So you have minus Fr here. So for me to look for any of these components, whether the acceleration or the tension or the frictional force on any of the sides, or probably the coefficient of friction here, I'll apply my Newton's second equation of motion, right? This is your net force. So for the first case, you have T minus m2g sine theta minus Fr equals m2a, right? So we have T minus m2g sine theta minus mu r equals m2a. This is your equation 1. But note that you have your r to be equals to w cos theta, right? Because the body is inclined, so the weight is w cos theta here. And what happens to your r? Because you will need the r, your r is opposite to the weight, right? So hence r is equivalent or equals to w cos theta. So in a way, I can say that I have T m2g sine theta minus mu w cos theta, right, to be equals to m2a. That's still my equation 1. So I can take this off as equation 1. So for the second side, what do I have? I have minus T minus FR plus M1G sine theta equals to M1A. Don't forget, your FR still remains mu R plus M1G sine theta equals M1A. Still, note that your R is still the same thing as W cos theta, right? Then your W here is M1G. Your W here is M2G, right? So these are the two equations to deal with. So for this question, the question says the system shown in the figure below has an acceleration of magnitude 2 meters per second squared. Assume the coefficient of kinetic friction between the block and the incline are the same for both inclines. Find the coefficient of kinetic friction. And 2, the tension in the string. For you to have been asked the coefficient of kinetic friction, you should know that the surface is a rough surface. Right. So let's quickly note out the forces on this system. So if this is 4 kg and the other is 9, it means that this is heavier than the 4 kg. Hence, the body accelerates in this direction. Right. So your acceleration is 2 meters per second squared. Now, if the body accelerates in that direction, it means that the weight bringing this object downwards is going to be positive because the body is moving in favor of gravity. Provided that this is our first mass and this is our second mass. Hence, we have plus M1G. The body is inclined. So we have sine 40 degrees. Opposite this would be your frictional force. Your frictional force tending upwards, that's Fr. And Fr is equals to your mu R. Your mu is your coefficient of kinetic friction because the object is accelerating. Towards the pulley is also your tension on both sides. Now, since this body is projecting upwards, it means that the body is against gravity, hence it will be minus G. So the weight bringing the object downwards would be minus M2G. It is inclined also, you have sine theta. So opposite the direction of motion, because this is the direction of motion, motion is going upwards, hence your frictional force will be against motion. So I can have my frictional force to be Fr, and that is still equals to mu R. Note that the frictional force will be negative because is against tension, is in this direction. Likewise, your force. Now, to your normal reaction, your normal reaction still exists, which is R, and it is equals to W cos theta. So we can say it is W cos 40 because the angle is 40 degrees. Now your weight tends downwards, but then we shouldn't have this weight here because it has been resolved to Fx axis and also to Fy axis. But we can have it here. Know that the weight is equals to M1G. Does that make sense? All right. For this other mass too, we have R, and R is still equals to W cos theta. Your W here is equals to M2G. Note that for this question, your acceleration due to gravity is given as 9.8 meters per second squared. So for equation 1, we still have to follow the template, which is your Newton's second law. Right. So this mark your next force. So for the forces on this axis, we're going to have tension, which is positive, minus Fr minus M2G sine 40 degrees equals to M2A. All right, if that is done, T minus mu R minus M2G sine 40 degrees equals to M2A. T minus mu, where your R is W cos 40 degrees, minus M2G sine 40 degrees equals M2A. T minus mu into bracket. Your W here is your second W. So we have M2G cos 40 degrees minus M2G sine 40 degrees equals M2A. So I have T minus mu. So M2G is going to give me into bracket of 4 times 9.8 cos 40 degrees minus 4 times 9.8 sine 40 degrees equals 4 times 2. A acceleration is equals to 2. C minus 30 mu minus 25.197 equals 8. So I have T minus 30 mu equals 8 plus 25.197. The whole of this gives me T minus 30 mu equals 33.197. This makes my equation 1. So for the other equation, so we have 3 forces acting on this 9 kg mass. The first is the weight of the body, the second is your frictional force, and the third is your tension. Note that since the weight is positive, the tension becomes negative, likewise the frictional force. So we have minus T minus Fr plus M1G sine 40 degrees equals MA, and the M is M1A. So here we have minus T minus mu R plus M1G sine 40 degrees equals M1A. So where our R is equals to W cos theta, cos 40 degrees. So we can have W is M1G, that's 9 times 9.8 cos 40 degrees. So we have this to be 67.565 newtons. Hence, we have minus T minus 67.565 mu on substitution plus 9 times 9.8 sine 40 degrees equals to 9 times 2, being the acceleration of the body. Being the acceleration of the body. So we have minus T minus 67.565 mu plus 56.5 694 equals 18. Then I have minus T minus 67.565 mu equals 18 minus 56.694. This gives me minus T minus 67.565 mu equals minus 38.696. So this becomes my equation 2. So what I have left is to solve equation 1 and 2 simultaneously. So equation 1 says T minus 30 mu equals 33.197. And equation 2 says minus T minus 67.565 mu equals to minus 38.694. This is my equation 1 and equation 2. So to solve simultaneously, add the two equations. So this, take out this. So what I have left is minus 97.565 mu equals minus 5.497. Divide both sides by minus 97.565. This cancel out this. So we have mu to be equal to 0.0563. Right. So to get this our mu, so to get tension, substitute 0.0563 for mu in equation 1 or equation 2. So equation 1 says T minus 30 mu equals 33.197. This is equation 1. So I can substitute saying minus 30 T minus 30 into bracket of 0.0563 equals 33.197. So what will be my answer? T minus 1.689 equals 33.197. T is equals to T is equals to 33.197 plus 1.689. That's giving us 34.886. On approximation, it is 34.89 newtons. Try this. All right, for case 4, we have the two masses, this particular mass, right, and this mass here. So the bigger mass is at the bottom, which is our M1, and the lighter one is at the top. So looking at the weight exerted by this body on this, we have the W would be equals to mg, right? So the normal reaction for this particular body would be R, and it's still equals to mg. Note that for this question, R is equivalent to W because the bodies are not inclined. All right, for the weight of this body, M1, it will be as a result of the weight of the lighter one and the weight of itself, right? So it means that we have the weight will be equals to the weight of one and the weight of the second, which is the lighter mass. So this tells us that we have m1g, right, plus m2g. So since g is common, we have m1 plus m2 into bracket of g, provided we factor out g. Now what will happen to the normal reaction? The normal reaction for this would be R, and it's equivalent to W, because it will be normal reaction for both. But I don't want to put it here. That's why I'm having it here. Right. If that's the case, I have it to be equals to M1 plus M2, right, into bracket of G. This is what we have for the forces acting upwards or downwards. Now, provided a force drags this to the right, it means motion will be towards this direction. And if motion is towards this direction, it tells us that the higher mass, which is this, move in this direction, and the lower would move in this direction. So between the masses is friction, and the coefficient of friction, provided that the body is accelerating, the coefficient of friction would be mu, and the coefficient of friction is coefficient of kinetic friction. Now, also, between this mass and the ground or the floor lies friction too, and the coefficient of friction here is still coefficient of kinetic friction. It is unknown. This is also unknown. Now, these two values are likely to be different because the materials are different. This, the floor and the mass here it is between two masses. So their surfaces are different, right? And that's why we have two coefficient of kinetic friction, right? So looking at the case, we have acceleration to move in this direction, right? So our acceleration is also unknown. Now, what happens if the body accelerates in this direction? So what happens to frictional force? Frictional force will be opposite the force of motion, right? Frictional force would act here between these two surfaces. So we have in this direction. So our frictional force is Fr, which is the same thing as mu r, and your mu is your mu k. That's coefficient of kinetic friction. It is coefficient of kinetic friction because you're talking about sliding friction since the bodies are moving. Does that make sense? So for the same body, it would also have a frictional force acting on it here, right? So I have frictional force, still the same thing as mu r, and it is mu k, right? These are the forces that will act on this body. So for the lighter body is moving in this direction, not because a force is pulling it here, but because the movement is as a result of this force. So we are not to take that force into consideration, right? So if that is the case, so what happens to if motion of the body moves in this direction? What happens to your frictional force? The frictional force must be in opposite direction. So I have Fr, which is the same as mu r. But notice that the r here is equals to mg. But the r here is equals to the weight here. If that is the case, what am I going to have for the values of tension? Because the two bodies are tied to a rope, and upon the pulley is the rope applied, right? So we have tension tending towards the pulley, right? So these are all the forces we are expecting for this case. So for equation 1, probably we take the lighter mass first. For forces on M2, for forces acting on M2, what am I expecting? I'm going to have C, which is a force, minus Fr equals to Ma. That is, you are following this template F equals to ma, which is your second Newton's equation of motion. Right. This is all I have for my first scenario, which is the lighter mass. Now for my FR here, I'll have T minus mu R, right, equals to ma. Don't forget your R here minus mu R, right? Your mu is mu K, right? And your R here is equals to M1 or M2G, right? And your mass and acceleration here is still the same thing as M2, right? So everything is equals to M2A. So this makes your equation 1. So for equation 2, which is the second case, we're going to have the first force, which is F minus these two forces, Fr and T here, and the last force lies here, which is the frictional force. For the first frictional force here, we're going to have Fr. So I have minus, the next one is your tension, T, right? Then minus Fr, everything to be equals to MA. And the MA is actually M1A, right? So we have F minus this frictional force, the Fr here, is actually as a result of this R, and the R is equals to this W because the friction here is as a result of the width of this mass. Does that make sense? So we can say that we have our mu R, mu Kr, right? So and our mu Kr is your coefficient of kinetic friction minus T minus mu Kr. But the R here is the other R, which is as a result of the second mass. And don't forget that the R is the same thing as this width here. Does that make sense? So I have M1A, right? So I have F minus mu K into bracket of M2G, then minus T minus mu K. So I have this R now is equals to that W, so I can say it is M1, or I have a square bracket, so I have M1 plus M2 into bracket of G, right? We'll have everything to be equals to minus M1A. This would actually mark my second equation. So this is what I'm expected to solve for the second scenario. For this question, the question says, in the system shown below, a force of 80 Newton accelerates the 5 kg body to the right. So we have acceleration here going towards this direction. Right? The acceleration is not given. Now find the acceleration. So that's what we're actually looking for. If the coefficient of kinetic friction is 0.04, right? So you are given just one coefficient of kinetic friction. It means that the friction between this surface and this surface up here are the same. All right, let's quickly note out the forces on the lighter mass kg at the top. So we have the tension tending towards the pulley. Opposite the tension is your frictional force because motion of the body tends to this direction. Since this object, the 5 kg is moving to the right, right? And you know that the 2 kg, the movement of 2 kg is as a result of the effect of the 80 newtons here. So if that is the case, what is the normal reaction and what's the weight of the body exerted here? So I have the weight would be equals to 2 times G, right? In other words, it's equals to your mg. So your m here is 2. So I have 2 times 10. Since your acceleration due to gravity is given as 10 meters per second square. So I have equals to 220 newtons. Right? If that is the case, we have normal reaction to be equals to, since normal reaction is equivalent to R, for this case, since the body is not inclined, so we have 20 newtons here. In other words, your normal reaction is still the same thing as mg. All right, these are the forces acting on that particular body. Now, for the second body, we have tension tending towards the pulley. We have the force here dragging it to the right. And between this surface here is your friction. And you'll be given the coefficient of kinetic friction to be 0.04. You have F1 will be equals to mu kr, right? Don't forget the r here is a result of the weight here. I have the weight here tending to the center of the earth. I have equals to w, but the weight is the result of the weight of this body and the weight of this body. So I have the weight of the first mass would give me w1, right, plus the weight of the second mass. So the first mass here is 2. So I have mass 1 g plus mass 2g, right? So the whole of that gives me m1 plus m2 into bracket of g, right? So what's my m1? My m1 is equals to 2 plus 5. That will give us 7 times 10 meters per second square. So that's giving us 70 Newton. So if the weight of this body is 70 Newton, it means that the normal reaction would also be 70 Newton. Hence, the R you're expecting here is 70. Does that make sense? All right. That will not be the only frictional force existing as regards this mass, because it's also in contact with the lighter mass here. So another frictional force is acting on it as motion goes this way, right? So in that case, I have Fr should be equals to mu r. But the r here is as a result of this weight here, because the friction is as a result of this body acting on this body, right? So I have the r here would be equals to 20 newtons, right? So my r here would be equals to 70 newtons. I think that is all for the forces acting on the bodies. Can we get the acceleration? We have so for our equation 1, which is the lighter mass, we have I'll be using another color of pen so we can see everything clearly. So I have Fr and T are the two forces on the lighter mass. Hence, if Fr is positive, then your T would be negative. It means that this tension here will be positive and the mass here will be negative. But I want to make it such that it's still the same, whichever way you do it, right? But I want to make it such that the mass pulling it here is positive and the tension here is negative, then the tension here would be positive, right? And this would be, the frictional force would be negative, right? So I'm giving preference to this 80 newtons. But if you still have minus, it's still the same, nothing changes, right? Just that here, the frictional force will be negative. Here, the frictional force will be negative because both frictional forces are acting on opposite direction to the force bringing the body to motion. Does that make sense? All right, if that is settled, can we quickly have the first scenario for the lighter spring? So I have T. I'm still following my normal equation, which is the equation of motion. So this is still your net force. So I have T minus Fr to be equals to Ma. The M here is your first mass, which is M1A. Does that make sense? So I have equation 1. So for the next equation, or before that, let's expand this to be mu K, right, R to be equals to M1A, where your R is equals to, your R is equivalent to W, and R is the same thing as 20 newtons, right? So for the second case, so I have this as my equation 1. I can easily take this off as equation 1, right? So the next case I have here is AT being the first force, which is positive, minus Fr, the first Fr here, that's what I'm noting here. Then I have minus T minus the second Fr, which is the least here, right, equals to Ma. The M here is the second mass. So in that respect, I have minus mu R, mu K R, right, minus T minus Fr. My Fr here is still mu K R equals to M2A. For this R, which is the first R, it is equals to 20 newtons. For the second, it's equals to 70 newtons. Right. So this is my equation 2. So I can solve both equations simultaneously. All right, what am I expecting? Let me have this here. I have C minus your mu is 0.44. Your R here is times 20, right? Then you have equals to your M1 is 2 times your acceleration. Your acceleration is unknown, so you have this as your equation 1. So I have 0.44 times 20. That's giving me 8.8, right? Equals to 2A. So this remains, I can otherwise have this as T minus 2A to have 8.8. Bring this here, the sign changes, right? So that is my equation 1. So for the second equation, I have 80 minus the first FR here. The R here is equals to 20 newtons. So I have 0.44. R here is equals to 20 minus T, right, minus 0.44. R here is equals to 70 equals, your second mass is 5. So I have this to be my second equation, but we can solve out the values. We have 80 minus 0.44 times 20 will give you 8.8, right, minus T minus 0.44 times 70, that's 30.8, equals to 5A. So these three values gives us 80 minus 8.8 minus 30.8. That's 40.4 minus T equals 5A. Minus T minus 5A equals minus 40.4 if you rearrange that. So this makes me my equation 2. Equation 1 to be T minus 2A equals 8.8, and equation 2 to be minus T minus 5A equals 40.4. Take the subtraction. In other words, add both sides. What am I going to have? I'm going to have this cancel out. This becomes minus 7A equals 8.8 minus 40.4. So that's giving me, this is minus 40.4, right? That's giving me minus 31.6. Divide both sides by minus 7. Minus 7. Acceleration will be equal to 4.51 meters per second square. Try this.